Hello and welcome to AULA UE. This is going to be a short video on the Poisson model. The Poisson model is a discrete model that describes a certain situation and gives us the probability of that situation. The Poisson model depends on a single variable, which in this case is our variable lambda, the Greek letter for the Latin letter L. Lambda is mu times t, that is the frequency times time. You have to be careful with the Poisson model because p of lambda is just like the binomial model. B of np, well, this would be p of lambda. So you mustn't confuse that p with the p of probability. It's the p for Poisson in this case. As I was saying, it depends on a single variable, lambda, and the random variable it describes, chi, is something that happens in a certain period of time. So lambda in this case is the frequency of something happening times the time in which it happens. Okay? So we'd have chi as something happens in the lapse of time t. As you can see here, I'm writing mu is the frequency, okay, of that thing happening. Imagine it's, for example, people going in through a door. Well, we'd have, I don't know, 15 people per minute. Well, that would be a frequency. In this case, we're going to do a small example of a toll booth, a toll for cars in a highway or something, where you get charged for using that highway or that speedway. Well, the toll booth has a certain frequency. In this case, let's say it has a frequency of 3 cars per minute. Fine. Well, in that case, let's give it a time. Let's say the time is 1 minute. What would the Poisson lambda be in this case? Well, in a lapse of time of 1 minute and a frequency of 3 cars per minute, we'd have 3 cars per minute times 1 minute equals, take minute cancels out with minutes, and we'd have 3 cars. So our lambda of Poisson would be 3 cars. Okay? Very well. Now we have our model. So as we know, the Poisson model describes a probability. The probability of chi being x. This is f of x. And this always is described through the following formula: e to the power of minus lambda times lambda to the power of x over x factorial. What does this describe? This describes of the probability of something happening in the lapse of time. So this is, for example, in the toll booth problem, what we'd be asking is, what's the probability of 4 cars going in the booth in 1 minute? Of course, the minimum quantity of times, the minimum amount of times that something can happen would be 0. And the maximum amount of times it can happen, well, technically it's infinity. Although, of course, well, physically sometimes it can't be infinity, for example, on a toll booth problem, because there are some physical restraints to it, but it doesn't really count in this case because we're trying to describe a mathematical model. So let's try to use this model we're talking about. Let's say that chi belongs to a Poisson of 3, and the probability then of chi being x in this case is f of x, which is e to the power of minus 3 times 3 to the power of x over x factorial. Okay? So what does this describe? This describes the probability of something happening x times when it usually happens 3 times per minute. Okay? So this is the probability of something happening x times in 1 minute when usually it happens 3 times in 1 minute. Okay, so we'd have a number of probabilities here. Of course, as we've explained before, the variable goes from 0 to infinity. So we can't really describe the whole variable as we could do in the binomial, for example, because it doesn't end. This is the hypergeometric and the binomial are both finite variables, but the geometric and the Poisson variables are infinite variables because they never end, okay, although they are discrete. So as you can see here, the probability of 0 is 0.5, the probability of 1 is 0.15, the probability of 2 is 0.22, the probability of 3 is 0.22, and then the probability of 4 is 0.17. This, of course, makes quite a lot of sense, because if usually there are 3 cars per minute, in a minute the most probable thing that will happen is that there are 2 or 3 cars approximately. The probability of there being 1 or 4 cars is less probable, okay, because usually there's 3. And the probability of there being no cars is even less probable. So what would the x of maximum probability be in one of these problems? Well, it's always lambda. For example, if I have a problem where, I don't know, we have a certain 3 cars per minute and time of 1 minute, as we were explaining here, well, the most probable amount of cars to pass in 1 minute is 3. In this case, mathematically, we also get the 2, but this is just because of the model itself. Out of sheer luck, it's 0.22 as it was in the other one. But it doesn't really describe the thing itself. So I hope you found this useful, and we'll see you soon. Goodbye.